Hey Trig class, what I'm going to do for our Chapter 5 review is go through some problems in your book that in a section at the very end called the Chapter 5 test, and it's on page 244. I'm going to start with number 1, and this is a basic problem. This type of problem is what we've been doing since the beginning of Trig, but in this chapter we're asked to use the identities that we have learned about to find the other 5 trig functions if given cosine theta is equal to 24 over 25. This is how the problem is stated, but you will be given something different here. I'm not giving exact problems that are on the test, unfortunately, for y'all. But let's go ahead and get started on this one. We have cosine of theta is equal to 24 over 25. Theta is in quadrant 4. So to use our trig identities, I'm going to use the fact that sine squared theta plus cosine squared theta is equal to 1. Y'all should have that one memorized by heart. If not, you know it's on your formula sheet. Or not formula sheet, your identity sheet. Okay, so how we use this is we solve for sine of theta by plugging in our cosine theta in here. It's not 25. 24 over 25. And some of you have been forgetting to do this right here. Square this number, okay? And whenever you square this number, if it's negative, it becomes positive, okay? So this right here is not minus, it is positive. It stays that no matter what because it is being squared. So we always, whenever we square this number, we are going to subtract it from 1, not add it if it's negative, okay? Let's do that. Going to square that number and then subtract it from 1. And what we get is 49 over 625. And that, when we take the square root of both sides, because that's what I'm doing in this next step, remember we get plus or minus here. And before we do that, let's say square root of 49 over 625 is 7 over 25. And since we're in the 4th quadrant, sine is going to be negative. All right, now that we have sine of theta is equal to 7 over 25, that looks like a 26, it's a 25. And then cosine of theta is equal to 24 over 25. To find the other trig values, such as tangent of theta, we're going to use, for tangent of theta, the easiest one I think is tangent of theta is equal to sine theta over cosine theta. Plug in the values for sine theta and cosine theta, negative 7 over 25 and 24 over 25. Now when you have a fraction over a fraction, then you multiply the numerator by the reciprocal of the denominator, and what happens there is our 25s are going to cancel out, and we get negative 7 over 24. Now to find the remaining 3, what we're going to do is just all 3 of these are the reciprocal functions of cosecant. Well, let's start with secant. Cosecant and cotangent. Well, the reciprocal of secant is cosine, so flip these two things around and you've got secant. So 25 over 24. Same goes with sine and cosecant. Flip those numbers. 25 over 7, and you've got cosecant. Cotangent, flip a tangent around, and you've got cotangent. So it's negative 24 over 7, and we're done. All right, so this is problem number 2, and what is being asked us of us to do for this is it says express this right here in it as a single function of theta. So simplify it. To simplify this, we use our trig identities, such as secant is 1 over cosine, and then I'm going to leave sine as sine, and then tangent expressed as sine over cosine. Okay, now let's do this. Well, these two things have the same denominator, so we can express everything over the same denominator, and this is going to be 1 minus sine times sine is sine squared theta. The numerator here, 1 minus sine squared theta, is equal to cosine squared theta, because that there is a Pythagorean identity. And whenever you have cosine squared theta over cosine theta, this cancels out with one of these, and so we are left with cosine theta, and we are done. We have expressed this right here as a single expression, a trig expression of theta. This is your problem number 4. What you're being asked to do on this one is find the exact value of cosine of 5 pi over 12. And you're going to have a couple more of these on your test. You're going to have one that deals with sine of some angle or radian measurement and tangent. What these are going to require you to use are your sum and difference identities. So this is the way we're going to use our sum and difference identities. Cosine of 5 pi over 12 can be broken down, and you can do this problem, and let me back up here. You can do this problem, 5 pi over 12, you can change that into degrees, convert it to degrees rather than dealing with radians. But I'm going to deal with radians for now because I know 5 pi over 12 is the same thing as pi over 6 plus pi over 4, which are, both of these are found on the unit circle, and you can find their exact values on that unit circle. Okay, so now that we have our angle broken down into two measurements that we do know exact values of, the cosine sum identity states this right here, that we can, let me write it down, cosine of A plus B is equal to cosine A times cosine B minus sine A sine B. Now, what we do is we take these two angles, excuse me, and plug them in for our A's and B's in down here in this identity. So cosine pi over 6, cosine of pi over 4 minus sine of pi over 6, sine of pi over 4. Now find the exact values for all four of these expressions here. So cosine of pi over 6 is the square root of 3 over 2. And cosine of pi over 4 is the square root of 2 over 2. The sine value for pi over 6 is 1/2. And the sine value of pi over 4 is the square root of 2 over 2. Now, multiply, subtract, simplify as much as possible. I don't know why I wrote a 6 over here, but that's supposed to be a 2. Let me erase it. All right now, so we get square root of 3 times the square root of 3, square root of 6, over 2 times 2, which is 4, minus 1 times the square root of 2 over 4. Now express this as over just one denominator, which is easy in this case, because we already have the same denominator. And there you have it. We are done with that one. So, like I said before, know how to do things like this right here. Use the sum and difference identities, but not just for cosine. Know how to use sine and tangent too, and be able, for the tangent one, be able to rationalize the denominator. All right, so this is problem number 8, and what we were asked to find is several things: sine of A plus B, cosine of A plus B, tangent of A minus B, and then also what quadrant A plus B is in. So let's do this. What these problems rely on are our sum and difference identities, which are written out right here. You will have on your card. And what we need is, okay, so we're given A, sine of A is equal to this, cosine B is equal to negative 3 over 5. I've been seeing a lot of this. Please do not mistake that this right here is equal to B. It is equal to cosine of B, and that's what goes inside this entire function right here. It doesn't go in for just the value of B. That number goes inside, or replaces what cosine of B is equal to. Okay? So do not treat the numbers you are given here like they are angles. All right, so now that I've gone over that, let's do this. So the first thing we need to do to start out any of these problems that deal with the identities, the sum and difference identities like this, is we are given sine of A, cosine B. What we need to find is cosine A and sine B. We need to find the other two trig values that we do not yet know. So we can do that with our Pythagorean identities. We could say sine squared A plus cosine squared A is equal to 1. From there, we can figure out, after we put in 5 over 13 and square it, square that, subtract it from 1. I don't know why I put a negative there. Let's erase that. And then take the square root of both sides, and you've got cosine of A is equal to 4/5. Or not 4/5, I'm in the wrong page, 12/13. Now, do the same thing, use the same identity to find what sine of B is equal to. So you're going to write sine squared B plus cosine squared B is equal to 1. Now replace your cosine beta, or B, with negative 3 over 5. Square it, subtract it from 1 and take the square root of it, and you get sine of B is equal to, now this is 4/5, 4 over 5. Now what we're going to do is take these 4 values that we are given and that we just found and plug them in here appropriately and solve for each one of these values. Okay, I'm going to do that on another page. Let me open it up. There we go. Actually, before I do this, I did want to state that, well, A here is in quadrant 1, so all of our trig values are going to be positive in that quadrant. And then B being in quadrant 2, our cosine value is going to be negative, but our sine value is going to be positive, so that's why I did not write negative 4/5. I wrote positive 4/5. All right, now let's move on. Okay, I'm going to go ahead and write down all of those trig values that we found so we can plug them in appropriately to the sum and difference identities that we have. So let's look at that. We know sine of A was 5/13. Cosine A we found to be 12/13. All right, so now that we have all of our values written down, let's plug them into our sum and difference identities. So sine of A plus B is equal to, this is how it goes. It says sine of A, so I'm going to take my sine of A value, plug it in, times cosine of B. So I'm going to multiply it by my cosine of B, which is negative 3/5. Add it to, the next part is cosine A, so 12/13, times sine of B, which is 4/5. Multiply these things together and then add them, and what we get is 33/65. Now let's find cosine of A plus B. Now this one is, what comes first is cosine A times cosine B, so 12/13 times negative 3/5, minus then sine A times sine B. So sine A, 5/13, and sine B, 4/5. Multiply, subtract them, and we get negative 56/65. Okay, now to use our tangent identity, because we are finding tangent of A minus B, not A plus B. We can't just simply divide these two like we have done before. We are going to use this. We need to know tangent A, tangent B, and we can find those values using our identities. Okay, there, now that's written. From here, we need tangent A and tangent B, so this is the way we're going to find it. Tangent A comes from sine A over cosine A, so that is going to be 5/12. And then tangent B is sine B over cosine B, which is negative 4/3. Now we plug those values in to our identity, our trig identity here, and say, oops, I think I meant to put minus and then plus. Yes, I did. Switch that around. Okay, so tangent A, 5/12, minus tangent B, negative 4/3, and then 1 minus both of these values multiplied now. Okay, now simplify this complex fraction down, and just to save time, I'm going to tell you it is 63/13. If you do not know how I got this value, let me know. I might show you before the test. But now the last part of this problem is asking us to find what quadrant A plus B is in. So to do that, what we're going to do is use the fact that sine of A plus B is positive and cosine of A plus B is negative. Well, when sine is positive, this implies that we are in quadrant 1 or 2. So either 1 or 2 here. And then if cosine of A plus B is negative, that implies that we are in either quadrant 2 or 3. Okay, so now looking at this, which one of these do they have in common? Well, that would be quadrant 2. So A plus B is in, I don't know why I wrote in. I did the same thing on the last page, is in quadrant 2. And we are done with this problem. All right, next is problem number 6. We're going back to that one. And it's telling us to use the half angle identity to find the exact value of sine of negative 22.5 degrees. So this one isn't too bad. What you need to know is that your half angle identity for sine is this. All right, it's this right here. Sorry, it just magically appeared for y'all. But anyway, so what we're going to do to figure out sine of negative 22.5 is using this identity. The value of our A is just going to be double the amount of negative 22.5. So 45. Because 45 divided by 2 is negative 22.5. And we need a negative here. All right, so since before we go ahead and plug things into the identity, let's look at this. Negative 22.5, if you think about it, that right there is going to be in the fourth quadrant, and the fourth quadrant means our sine value is going to be negative. So instead of saying plus or minus, I'm just going to put a minus sign here. And say 1 minus cosine of 45 degrees. Sorry, that was a badass. There we go. And that's over 2. And now what we need to do is find the exact value for cosine of 45 and then simplify everything inside the square root. Oh, and this is going to be negative 45 in here. And a negative angle inside cosine is the same thing as the positive value. All right, now simplify this down and we should get this right here. And we are done with that one. Oh, don't forget the negative on the outside. Now we're done. Okay, also on this one, before I go to the next problem, expect that you're going to have more than one of these types of problems where you have to find the exact value of a half angle. And you're going to have to use your other trig identities for half angles also. Okay, let's do the next one. All right, guys, let me put my page back up. Okay, there we go. Now on this problem, it is number 9. We are given this information here that cosine of theta is negative 3 over 5 and that theta is between these two values here. What this means is theta is between, let's see, that's 90 and that's 180, so quadrant 2. And we're asked several questions here, and this is probably how it's going to show up on your test too. We're asked to find the double angle values for sine, cosine, tangent, and then the half angles for I'll probably do all three on the test, but here it just lists cosine and tangent for this problem. So let's get through this one. What you're going to have to do is use your double and half angle identities, which I think I've pulled up here. Notice on the double angle identities, let's look at these. You need many times you're gonna need to find sine of A and cosine of A and tangent of A for to find any of your double angle identities values. So from what we are given, let's go ahead. Since we're given cosine, we can go ahead and find sine. That would be the first thing I do is find everything before trying to apply any of the identities, any of the formulas that we have. Okay, so let's find sine by using the Pythagorean identity. I'm just going to write it out a little bit differently. It's going to be the plus or minus square root of 1 minus your cosine value, which is negative 3 over 5, square it. And since we're in quadrant 2, sine value is going to be positive, and we're going to have this sine of theta equaling 4/5. Okay, so now that we know cosine and we know sine, we can also figure out what tangent is equal to. So tangent of theta is equal to, well, sine over cosine. So it's going to be equal to negative 4/3. Now let's apply all of our double angle identities to find. First, we are asked to find cosine of 2 theta. So cosine of 2 theta, if we apply one of the identities, it says to cosine of theta is equal to 2 times cosine squared theta minus 1. So in for cosine, we are going to plug in our cosine value that we're given. So 2 times negative 3 over 5, square it because it's cosine squared, then subtract 1. And from this, we get negative 7/25. And that's all you do for that one right there. We have found the value for cosine of 2 theta. Now let's do that again, but we're going to find sine of 2 theta. And using its identity, that is 2 sine theta cosine theta. So this is the reason, one of the reasons why we needed to go ahead and find our sine value is because this identity uses our sine value to find the exact value of sine 2 theta. Now we just plug those in. So 2 times sine theta, which is 4/5, and then cosine theta, which is negative 3/5, now multiply it together. We are going to have negative 24/25. And there we go. We found sine of 2 theta. Now to find tangent of 2 theta, well, we could use this identity right here that says tangent of 2 theta is equal to this mess here. Or we can use the fact that we know cosine 2 theta, sine of 2 theta, and that tangent of theta is equal to sine over cosine. I need to put a 2 right here. I'm just going to back that up. So tangent of 2 theta is equal to sine of 2 theta over cosine 2 theta. And when you divide these, you get a positive 24/7. And we're done with that one. Now we're asked to find the half angles of cosine and tangent. Let's do that here. Cosine of, let's see, theta over 2 is equal to, now before we go and find the half angle, we need to figure out what quadrant our half angle is in. And this is how we do it. We know that this theta, original theta, is in quadrant 2. Well, what happens if we divide everything by 2? We get pi over 4 is less than theta over 2, and it's less than pi over 2. This right here, pi over 4 to pi over 2, that means we're in quadrant 1. No, I just wrote 2. We're in quadrant 1. So, if we're in quadrant 1, all of our sine, cosine, tangent values are going to be positive. So in the formulas that we were given for the half angles, we don't have to put plus or minus. We can just keep it as positive, plus 1 plus cosine theta over 2. So that's the half angle for cosine. And what we do, since we already have all the values that we need to find, we just plug them straight in. So 1 plus cosine theta, negative 3 over 5, all over 2. Simplify this fraction on the inside of the square root, and we get, let's see, 1 over the square root of 5, which rationalize that, and we get square root 5 over 5, and that is our answer there. Now, let's find tangent of our half angle. And tangent of theta over 2. All right, gonna keep on going. Sorry, I was interrupted. So is my train of thought. Oh, okay, so sine of theta over 2 is equal to, this is our identity, sine theta over 1 plus cosine theta. We have sine theta, we have cosine theta. Plug those values in. Sine theta is 4/5. Cosine theta is negative 3/5, so let's just go ahead and say minus 3/5. Simplify this fraction down, and we get 2. And we're done. So that's the end of that problem. It's going to be much like what I asked you on the test too. Now, we're going to do some verifying identities. So if you want to stop your session here, I think this is about all we're going to do on our first portion of the test. Our second portion of the test will happen on Thursday. So stop here if you would like and watch the rest of this later. All right, so this is an equation that we have to verify that it is an identity. And remember, to verify identities, many times you are going to have to either, there's many algebra skills that you're going to have to use, such as factoring and foiling and rationalizing the denominator or something to that effect, okay? So you got to have all those skills behind you in order to do this part right here. Now, you are going to have about 4 to 5 of these. I don't think I'm going to put any more than 5 on your test. So let's go over this one here that I have first. What I'm going to do is take this side right here and try to simplify it down to make it look like this side of our equation. So tangent squared x minus sine squared x. What I would do first on this one is put everything in terms of sine and cosine, or sine or cosine. So tangent squared x is sine squared x over cosine squared x. And now what we have to do at this point is put everything over one denominator. So get a common denominator. And how we're going to do that is by multiplying this one by cosine squared over cosine squared. All right, now I'm going to keep this all in its factored form. So sine squared minus sine squared times cosine squared all over cosine squared x. Okay, now I'm going to factor a sine squared out because both of these terms have a sine squared. Whenever I factor out a sine squared from sine squared, I'm left with 1. And whenever I factor a sine squared out from this whole thing, it just gets rid of sine squared, and I'm left with cosine squared. Now, this is over cosine. Okay, now what I do, 1 minus cosine squared is sine squared. So what I have here is sine squared times sine squared over cosine squared x. Now, that should look familiar. That is up here. What I would do at this point is separate these out. We have sine squared here, and then over, well, sine squared over cosine squared, which is tangent squared. And then sine squared right there. Now, another way of writing tangent squared and sine squared multiplied each other is just like this. This right here, if you were to apply the exponential rule, you would apply it to both of the terms that are being multiplied together. So you would get tangent squared. Sorry, that is really sloppy. Tangent, still sloppy, but oh well. Sine squared. You can either show that fact that these two are equal to each other, or you can just go one more step and say that this right here is equal to tangent x sine x all squared. And we're done. Here's another verifying the equation is an identity. This is the more complicated side, so make this side look like this one. And how I would start this out is change all of your tangents and cotangents into terms of sine and cosine. So tangent is sine over cosine, and cotangent is cosine over sine. And then same thing goes in the denominator. All right, now the simplest way to go about this one is multiplying it to simplify a complex fraction. We've learned in algebra, one technique is to multiply numerator and denominator by the least common denominator. Our LCD in this case is going to be sine x times cosine x, or cosine x times sine x, either way. So cosine x times sine x, both numerator and denominator. Okay, this is going to distribute across this right here. So multiplying it to both of these, and then this one to both of these. What happens here is whenever we multiply cosine x times sine x to this one, our cosines cancel out, and we're left with sine x times sine x, which is sine squared x. Then doing the same thing here, our sines cancel, and we are left with cosine x times cosine x, which is cosine squared x. Going to be left with the same thing in the denominator, except there's going to be a plus sign in the middle. Now, sine squared x plus cosine squared x, that is equal to 1 because that's one of our Pythagorean identities. This right here is, let's see, we can, I'm trying to look at this, we can take our Pythagorean identity and rearrange it. Remember this right here. That's our Pythagorean identity that we're using. If we rearrange it and solve for cosine squared, what we'd have that there. Plug this portion into cosine squared x. So we have sine squared x minus 1 minus sine squared x. And then that, if we distribute that negative out, we would get sine squared x plus, well, minus 1 plus sine squared x. Well, we have two sine squared x's. That means we have 2 sine squared x, then minus 1. There we go. That is what we were looking for. All right, so this is the last verifying one I'm going to do. If you have any more questions on verifying, please come see me. Take the time in the morning in the whenever I have free period or something to come see me before the test. But what we're going to do here is verify that this is an identity, and we're going to use the right side to make it look like the left side. So taking the cotangent A minus cotangent or tangent A, I'm going to change everything into terms of sine and cosine. I'm going to skip rewriting this. I'm going to say that is equal to cosine A over sine A minus sine A over cosine A. And then same goes with the denominator, cosecant A and secant A. Change it into terms of sine and cosine, which it's 1 over sine A and 1 over cosine A. Just like the last one, we're gonna, we have a complex fraction here, multiply by the least common denominator. And again here, it's sine A, cosine A, or cosine A, sine A, whichever way you want to put it. Cosine A times sine A. There we go. Now we have this right here in the denominator would combine to be 1 over sine A cosine A. These two denominators are being multiplied together, and when we multiply, these cancel out with these up here. And again, distributing this to both of these terms here, we would get our sines would cancel, and we'd get cosine squared A minus sine squared A. And if you look on your sheet or your identity, where your identities are, you would see that cosine squared A minus sine squared A is equal to cosine 2A. That is one of the forms of cosine 2A. And we are done. So I hope this video helped you all out, and I hope you do very well in the test. I'll see you all later. Goodbye.